Okay, we're going to go over the multiple choice questions. Why doesn't that one go? Okay, you guys can sit in the dark. That I handed out yesterday, that Matt handed out for me yesterday. If you're going to be in the early class, you have to pay attention. Otherwise, I'm going to make you go. I'm such a mean person. I'll make you guys split apart. Okay, so Matt said there was a lot of confusion about questions when this was handed out, but I think some of you weren't there because you didn't get the handout. So all the questions, these are to help prepare you for the quiz on Friday. Everybody realizes that the quiz is online on Friday? Yes. Okay, well, you guys were sitting here. So that means that you don't really have to show up in class on Friday because your quiz is online. Okay? You've not taken a quiz online in here before? Okay, you have 50 minutes. You get one shot at it. So when you log in, be ready to go because you don't get another shot. Okay, don't go wash dishes and do something else because it'll time out on you. That's why I handed it out. You're not supposed to use this, but I don't know how I'm going to keep you from using this. Okay. Question. 24. 50. So, okay, so let's go through these, and I will actually post the answers to these questions online after class today, too. But I thought I'd go through these and go ahead and record it for the students that are online. I need to slide this over here. Okay, so the first question, so this will help us understand oxidation reduction, okay? So which of these statements about rust is incorrect? Okay, so rust occurs as a result of transfer, well, they didn't write that right, did they? As a transfer of electrons. What did we talk about with oxidation reduction? Aren't there electrons transferred? Didn't say which way, so there are electrons transferred, so that is not incorrect, is it? Okay. Rust is a result of an oxidation reduction reaction. Is that true? Okay. Rusting is accelerated by the presence of salt water. Yes. Rust costs 10 billion worth of steel destruction annually. Yes. That was actually in the slides itself too. So if you're confused about this, go back through the slides. It follows the slides exactly. Okay. Iron is reduced and oxygen is oxidized during the rusting process. And why is that incorrect? Iron's oxidized if it's rusting, right? So that's kind of common sense if you read through it. So did everybody reason that through? Okay. You see how we reasoned it through? All right, so that's what you should do with all these questions. All right, so let's go ahead on to number 2. Okay, during oxidation reductions, okay, we covered this at least 3 times. The substance which loses electrons is blank, and the substance which gains electrons is blank. Okay, so what's our definition of oxidation reduction? Yeah, and how did you remember that? Because isn't the charge reduced in reduction? Okay, because Matt told you that. Okay, but that's the other thing that we talked about is if we're worried about reduction, remember the charge gets reduced, and if you add electrons, your charge gets reduced. Okay, so which answer? Is it A? Okay, if you got A, then that's correct. Okay, so if there's any questions, I'm just going through this so you reason through what the answer is, why it is what it is. I thought that would be a good way to do this. Okay, which of these characteristics on number 3 is associated with oxidation? Well, we just went through some of that, isn't it? Do we lose electrons in oxidation? Yeah. Okay. Do we gain hydrogen? What's the process of gaining hydrogen is more a reduction process, isn't it? Okay. What about gaining oxygen? Because oxygen is the most common oxidizing agent. So you should have picked 1 and 3, which is C. Everybody got that? Mackenzie, did you already do these? Or okay. Okay. So just make sure you ask questions if you're not sure exactly, because that's what this is for. Because this is your really review for all the things we know about oxidation reduction. Okay. I'm not following this very well. I need to come down. So let's do number 4 here. Which of these statements about redox reactions is incorrect? So what's the first thing? What is redox? It simply means oxidation reduction. Okay, and we're supposed to pick out what is incorrect. Okay, letter A, oxidation is the gain of oxygen. That's true, isn't it? Because the iron would gain the oxygen. Just go back to thinking about that. Oxidation is the loss of electrons. Well, somebody over here just said that that was true, right? Was the loss of electrons? So we've got 2 of them that are correct. Reduction is the gain of electrons. I think we just said that was correct too, didn't we? Oxidation is the gain of hydrogen. Is that true? No, that's false. Okay, so your answer should be D on that. Everybody get that without me? Good. Oh, you're making me feel so good when you're yelling back there. I know it's Wednesday. All right, so let's look at number 5. It says, which of these is not an oxidation reduction reaction? Okay, so what we have to do is see if we have the gain and loss of oxygen and hydrogen, right? What happens in the first equation? Copper loses oxygen, but water gains oxygen, so that's an oxidation reduction, isn't it? So that's not. That is one. Let's go to the second one. What happens there? Same thing, doesn't it? I lose an oxygen, I lose an oxygen, and I gain an oxygen. Well, on both sides. If you lose one on one side, you gain it on the other side, right? For balancing. Okay. Yeah, so that's an oxidation reduction too. What about C? Does anything happen there? Yeah. I've got electrons transferring, right? Because I go from I- to I2. Okay, so that's an oxidation reduction. So we got 3 that are oxidation reductions so far. What about D? Right, and we've got electrons gained on that other side too. So that's an oxidation reduction. What about E? What do you okay. All right, but why is it E? What are those 2 things on the left side? What are both of those compounds on the left side? What did we just finish covering before oxidation reduction? And what are those 2 things on the left side? What's hydrochloric acid? Hydrochloric acid. There you go. Got an acid. Sodium hydroxide is a base, and it's making a salt and water. Okay, so it's actually a neutralization reaction. Okay, so we're tying 2 things together here. So you should have recognized that was an acid and a base going to salt and water. Is that easier to see now as to why it's that way? So you don't see electrons transferring. I'm watching all these yawns going on here. So E would be the correct answer, whether you wanted to know why it was correct or not, okay? Okay, for number 6 on the second page, remember when we talked about oxidizing agents and reduction agents? If an item is oxidized, or an element is oxidized, it's the reducing agent. If an element is reduced, it's the oxidizing agent. Okay, so what we have to do is figure out what's doing what in this reaction. So if we look at this equation, we want to find out what is being reduced. Because it's reduced, it would be the oxidizing agent as you look at that. Isn't that what's happening? Okay, so MnO4b is the correct answer. Does everybody understand why that's that way? Right. Okay, so now we got to see what's happening, which one is being oxidized in the second equation, in 7, excuse me, because it would be the reducing agent. Okay, so what do we see here? We see hydrofluoric acid plus Cl2 chlorine goes to F2, okay, plus HCl. So what's happening to the charge in hydrogen fluoride? H is a +1, F is a -1. Okay, so when I go to the other side, what's the charge on the fluoride? Right, it gets 0 because it's a 0 because it's F2. Okay, so it goes from, it gains, does it? Right. So if we look at, no, actually the hydrofluoride is the reducing agent because it's oxidized, right? Oxidation, the charge would increase, right? So it goes from -1 to 0. Yeah. I was waiting for somebody to. I couldn't understand him, but that's okay. So you did say A? I did not hear that.
A came out he missed the kindergarten through first grade deal.
Okay. So does everybody understand why it's the reducing agent? Let's okay. Let's go on to 8. Which of these substances is the most common oxidizing agent? Hint on the oxidizing. That would be correct. C, oxygen is the most common oxidizing agent. It's not always, but it's the most common. Okay, so if that's on the quiz, I hope you get that right. No, I'm just, yes, subtle hint, okay. Okay, what about 9? Which of these substances is the most common reducing agent? Yay! H2. Okay, because don't we talk about oxidation being the gaining of oxygen and reduction is the gaining of hydrogen as one of our things? It's either hydrogen, electrons, or oxygen. Cool. Always go with A? I don't think you should always go with A. No. Okay, let's go through question number 10. Okay, for question number 10, you have to know what respiration is. What is respiration? Is it the opposite of photosynthesis? It was in the slide, so you'd have to go back and look. Okay, so what happens? It says, which of these statements about respiration is correct? Okay, so I'd have to open up the slides if you aren't familiar with what respiration is. But basically, we're taking our glucose and breaking it down, right, and making it into energy for us. So A is correct. Respiration is an exothermic process. That is correct. It gives off. That's right. You're gonna see there's more than one correct here. So if there's more than one correct, what does my answer have to be? My answer has to be E, right? Because look at carbon dioxide and water are produced during respiration, aren't they? We're breaking down sugars. Okay. The final step of digestion requires oxygen to oxidize glucose. That is correct. Okay, we're going to have to get the peanut gallery to quiet down over there. Oh, yes, I can see that.
The thing is the peanut gallery is pulling people here.
No. I'm trying to record this for the other students as well. So, and I'm glad you're here. So again, if we work through this, it's got to be all the statements are correct. Okay, so we're on to number 11. The process by which plants form glucose is known as B, photosynthesis. Yay! I know. Okay. All right, we've just got we got through question 11, so we just got 9 more to do. Okay, so let's see if we can work our way through that. Let me move on through here. So, during respiration, we just talked about respiration, didn't we? Okay, sugars are blanked in the presence of oxygen to produce carbon dioxide and water. So if I'm taking sugar and I'm producing carbon dioxide and water, okay, so I'm taking sugars and it's in the presence of oxygen. So I have to add oxygen to it. So it will be oxidized. Yeah. Because you're producing carbon dioxide and water. Okay? So the correct answer was D. In number 13, you've got 5 different things to choose from, and it wants to know which of these pairs represent reactants in photosynthesis. So what side of the equation am I talking about on reactants? Isn't that what I start with? To make something, my products. So what do I make sugars out of? That would be correct. It would be C. Because I can't make sugars out of oxygen and carbon dioxide, can I? And I don't use carbon dioxide and sugars. I need water plus CO2. And I'm not going to use oxygen and water, or water and sugars, so C is the only correct answer. Okay. So, we just talked about photosynthesis, and we just said it takes water and carbon dioxide to make the sugars in photosynthesis. So now you have to pick out on number 14 which of the equation represents photosynthesis. Yeah, because you've got water and carbon dioxide on the left, right? That makes it pretty easy with the way these go, doesn't it? As you work through it. That wasn't difficult. Was it? Negative. Good. I'm getting one answer from the peanut gallery. Yes, because I have water and carbon dioxide. And I'm making sugars for photosynthesis. Okay, so think about what I asked. I said E. E as in Edward. Sorry. No. E as in Edward. Sorry if you did not understand me. E as in Edward. Well, I have to pronunciate clearer. Okay. So now we're going on to 15. 5 more questions left to do. If you can do these questions, you should be okay on the quiz. All right, so on 15, we have an equation with iron oxide plus 3CO goes to 2Fe plus CO2. Which of these substances is oxidized? And say that again. And why did you choose B, as in boy? Well, actually it gained an oxygen, didn't it? It gained an oxygen. On Fe 2O3, the oxygen was taken away, so that would be reduced, wouldn't it? If you lose oxygen, that's reduction. It would be the CO, yeah, B. Did you not say B or did you say E? Final answer is B. B as in boy. I better just say so you understand what letter it is. Man, I didn't think it'd be this hard to go through questions with you guys. Woo! Okay, we're getting there. Okay, on 16, do you think you can pick out which ones are oxidation-reduction reactions? Remember, we have to have oxygen going one side or the other, or electrons being transferred? Well, what's happening in number 1? Isn't hydrogen going somewhere? Okay. I'm going from an plus. Do you see there's oxygen going both in 2 and 3? 4 has got electrons transferring, 1 has got electrons transferring. So it's all of them. Okay, so remember the definition of oxidation reduction. We've got the gaining of oxygen for oxidation, reduction gains electrons or hydrogen. Okay. All right. We're on to 17. So if you don't understand why those are all oxidation reductions, we need to talk about that. That's why I wanted to go over these today and give you some time to mull these over. Okay, if you don't understand these, then we need to go through the slides again. Okay, and in the slides it told us where the oxidation and reduction occurred as far as whether it was the anode or the cathode, didn't we? Okay. So what occurs at the anode? Do you remember? So what's happening with oxidation? Are we gaining electrons or losing electrons? So if I lose electrons, would that be what's happening at the cathode? You guys are guessing, aren't you? Okay. So, well, let's just go through all 3 of the letters on here. So you just got, it wouldn't be oxidation, would it? Okay. It wouldn't be gain of mass or reduction, would it? No, because you can't gain and not lose. You can't loss of mass. So it's not going to be either C, D, or E. Okay, so now you're down to 50% right. Correct? So you either have oxidation reduction or reduction oxidation. Yes, it does. So A would be right. Oxidation occurs at the anode and reduction occurs at the cathode within a battery. Okay. So which of the statements, so if you can't realize that, then just kind of write it out and see what's happening at the battery level. And here we're looking at a lead acid battery on number 18. So you've got lead plus lead oxide plus 4 hydrogens plus sulfate going into lead sulfate and 2 waters. Okay, so what's happening to that? Lead is oxidized because we take lead and we put the sulfate on it, so it's oxidized. Okay. So you're going to have to go back and look at the slides to review this question, aren't you? To see, because we did go over this in class with the slides, so if we review that. But the lead oxide, I can't get it. The lead oxide will act as the cathode. Okay. Both the anode and cathode reactions result in the formation of PbSO4. That is correct. They go back and forth. And the lead oxide can be reformed from the lead sulfate with the application of an electrical current. Isn't that what you do with your car battery? I mean, when you're running it, the electrical current makes it go back the other way, so it recharges the battery. Okay, so the fact that even if you didn't know C, the fact that 3 out of those 4 were correct, you'd say all these statements are correct. Okay, so it's E as in Edward. Okay, and I would review that if you're not sure of what's going on with that, the battery. Okay? Okay, I think number 19, you should be able to get. It's fairly, I mean, that's kind of a common sense question, and we did go over it in the lecture. Which of these methods are utilized to help prevent the rusting of iron? Painting iron, does that happen? Yeah, isn't that what happens when you're undercoating? You're painting it with zinc. Treating iron with sulfuric acid. Would you do that to keep it from rusting? I don't think so. So two better not be in there. Coating iron with a metal which is more likely to oxidize. Yes, so we should find the answer that says 1 and 3, which would be letter C as in cowboy. No, that's boric acid. But who cares? It's an acid. What would an acid do to a metal, guys? Right, but it's going to break it down. But it's But it does oxidize to weld, but you're trying to prevent rusting or oxidation.
I was just wondering, it's like I don't need a weld, gas weld.
It helps it hold together, but we're trying to prevent the iron from breaking down. So when you break it down, it'll stick better. So yes, you're right in what you're talking about, but we're trying to prevent that from happening.
I was just wondering.
Yeah, absolutely, you're correct. Man, you're thinking. Good for you. Okay, we talked about antioxidants in class. That seems like a long time ago. That was in the slides too. You've probably seen these on commercials and everything else. Which ones are antioxidants? I think we talked about vitamin E is sold on TV as an antioxidant, isn't it? It's supposed to help prevent whatever ails you. Vitamin C and beta-carotene is also sold as an antioxidant, so that would mean it'd have to be all the above. Okay? Does that make things a lot more clear now? Okay, and then tomorrow, if you haven't read through the photosynthesis part, the chapter 13 on just how the nutrients are taken up, we'll discuss that tomorrow so that we can relate oxidation reduction. No lab, just class. Yeah, I announced that last week too, and I put it on Canvas. So I will announce it again on Canvas. No lab, just come to class. And then we have the online quiz on Friday. Okay? So, and I will have handouts for the last part of class for organic chemistry. I'll give them out tomorrow. Thanks, guys.